Hey, everybody. Welcome to class. A couple of things. I like to keep this interactive. If you didn't come to the first session, feel free to ask questions uh, in chat, or go ahead and raise your hand. And once you're done, lower your hand if you do put it up, and then we'll kind of go from there. I am going to apologize if there's any background noise. I have the door to my office open because my office is in the corner of our house. And for some reason, the air conditioning doesn't quite cool this room down. So I've got a door open so I don't swelter while we're online here. I would literally melt in front of you probably. So apologies. All right. We just talked about this. Camera on during class. I'm okay if you don't have your camera on. If you're asking a question, if you could turn it on, that would be great. But if you want to have camera off, that's fine. And if you're a camera off person and you don't want to be on camera, I'm cool with that too. I think it goes without saying everybody knows how to do this now. Mute. If there's some background noise, I might mute wherever it's coming from, unless it's me. And we'll work through that. Raise hand, talked about that. If you raise your hand, please turn your camera on if you're a camera on person, and I'll get to you as soon as we can. And then when we're done talking, if you can lower your hand, that would be cool too. And I think we're good on that. Class schedule. The last time I did this class, we did more lecture, and I think it was too much. So what I'm trying to do this time is distill it down. I can almost guarantee you I will always go over. 45 minutes is not going to be enough. It's probably going to be a full hour. And then we can always do Q&A after. I don't have any hard, fast time limits. So as long as y'all have questions, we can hang around and answer. We've got 7 assignments that are building into a capstone project. Paulina can plug her ears. I am not a real stickler about the assignments being in except before the end of the course. I know everybody's got work and lives and things like that. So if you do the assignment and you turn them in, I will get you credit. And then office hours are going to be the 30 minutes after class. I'll hang around if you want. And if there's no questions, we can leave too. Discord channel, I look at that every day. If you got questions, let me know in Discord. And then if you need something that you don't want in Discord, we can do a direct message, or you can email me, and I'll make sure I post my email again in the Discord chat. So the office hours are your time, so please use them, right? And I'm here to facilitate and do the best I can to make sure I answer your questions. But it's super important, right? If the time is set aside, and I won't say it's wasted if you don't use it, but I'm here to answer questions. Discord, I think we've talked about that, the virtual study hall aspect of it, and then we'll get certificates and letters and stuff like that at the end. I think one thing that would be pretty cool is the capstone project would be something that'll be portfolio worthy. Students have used them in interviews, show them to their employers about what they're doing. You can take that and extend it and refine it over time and use it in your day-to-day work. But it's something that is, not a lot of people can do. So you definitely want to make sure that you get the most out of you can out of the capstone project, and that will make sure that you have a takeaway that is worthy of the time that y'all are spending here. So today, I think the biggest thing is this is kind of a slow, easy start. We're not gonna hit it too hard right out of the gate. We're gonna build over time this course. I completely redesigned this from the first time I did it. And I want to make sure that all the lessons build on each other and all the labs lead you up to a successful capstone project. And by the same token, I don't know everything. There's probably people who have more experience in certain areas than I do. Feel free to contribute if there's something we can do to make this class better. I'll certainly do it. It's not cast in stone. If there's a topic you want to see or a direction you want to go, let me know, and we'll see about how we can incorporate that into the class because I'm sure we all have similar interests. And it's useful to hear from you as opposed to just from my perspective putting this together. So I think the key lessons are, lesson 4, we're going to do our first hands-on for threat detection. We'll have some guest speakers from industries, lessons 8 and 11. Lessons 13 and 14, we'll be talking about adversarial AI. This is, cutting edge stuff. We're not certainly at the cutting edge, but understanding it, I think, is very helpful and, kind of grokking what's going on underneath the covers. And then, lesson 16, it's, kind of we're going to gaze into the crystal ball, what's coming in the future, right? Things have changed super fast just in the year since I first taught this course. It's amazing how many changes have come to the forefront, how much better LLMs are and the things that you can do with them. There's some pretty mind-blowing examples that we've been able to put together, and I think you guys will really dig it. And we'll get under the covers. And at the essence is, I don't know about you guys, but I've never sat down and pounded out 1,000 lines of code. But if you work with LLM, you can generate 1,000 lines of code in, I won't say short order, but with a few hours of hacking. So we're teaching as part of this course how you can use LLMs to get results, as opposed to trying to teach you how to be a Python programmer and a data scientist and everything. One of my former colleagues at Amazon had a master's in data science, and he said a master's in data science is kind of worthless today because of LLMs, because I can get a result just by asking the right questions. And I think that's what we're trying to optimize for here, is giving you the skill and the ability to ask the right questions and to work with LLM to get to deliver results. There was a topic I posted in the Discord channel where a professor from the Paul Allen Computer Science Institute at University of Washington said that, being a programmer is obsolete. We're not going to teach people to program. What we're going to teach you, hopefully, is how to get your foot in the door to be an AI wrangler and to use it to get results with cybersecurity. Okay, assignments. If you're working ahead, you saw that I posted the first assignment already, how to install, Anaconda and get a Jupyter notebook set up. I did that so you have a couple of days to work on it. This is another case where your LLM will be your friend. Pick one, use it, and it can be super helpful. Anaconda is pretty straightforward to set up, but if you need a couple extra days and you want to ask some questions, it's probably good to stick your toe in the water early if you're not familiar with doing that. And as you can see, we're kind of building to the capstone project. We'll start with data pre-processing, some basic setup and data import, some feature engineering, visualization, model training and evaluation, and the final model and validation. And then that will feed directly into your capstone, and we'll build it as we go. The labs that we do during class also are arranged so that they talk about these topics. So you should be able to go from the lab to homework and get results, and also build out the end result capstone project through the course of this. So it's not like a giant final homework assignment at the end. We want to try and build up to this because, again, I know everybody's got things to do, and I think it's better if we do it in bite-sized chunks, and we'll talk about how we do that as we go forward. Okay, any questions so far? All right. So let's talk about the objectives for this lesson. By the end, we'll be able to do some basic things, define AI and its key types, identify the core cybersecurity concepts, and explain the importance of AI and cybersecurity with some real examples. So we're laying the foundation. By the end of the class, you should feel confident explaining AI to a colleague and understand how this applies to cybersecurity. So just kind of a show of virtual hands, how many people have worked with AI before? And just raise your hand. I think we all have. I mean, you can't do anything anymore without working with AI, it seems like. And how many people consider themselves a cybersecurity profession? Again, lots of hands. But is there such a thing as an AI and cybersecurity professional today? I don't think I'm one, but I kind of dabble in both. And that's what we want to try and do is how do we use AI to do better in cybersecurity? So we got a lot of experience in the room. I think that's great. And I think it's going to be super helpful as we go forward. All right. And I'm going to apologize in advance for the designs of these slides. I think they're super creepy. So I don't know if anybody else agrees with me or not, but it reminds me of like the opening to Westworld or something. I get kind of creeped out by it, but that's okay. You feedback to Paulina for our design team that we have creepy AI art. He's just waiting for the singularity. Okay, so AI it isn't about robots taking over, right? It's I think everybody thinks that AI is terrible. AI is actually super useful. I used to think I was pretty good at Google searching, and then it's like AI is supercharged search, right? It gives you stuff in context. I mean, a couple of years ago, if you wanted to search for something, you're going and you're grubbing through Stack Overflow looking for things and trying out a bunch of answers. And AI kind of organizes that and gives it to you in context. And I think that's super useful. It's about pattern recognition and decision making, right? It is based on what questions you're asking using plain text, the results are fed back to you in a way that is most likely going to fit your use case. However, it's not perfect. You're going to see this as we go through and start using LLMs to generate code for some of these examples. Sometimes it doesn't work. Everybody's going to have this experience. You're going to end up with a giant bunch of spaghetti code with debug stuff in it from your LLM, and you're going to say, where did I go wrong? So we're gonna try and figure out ways to work through that together. I've been hacking on this course for the past 6 months, so I tried to practice what I teach and use LLMs to generate code. I went through and I wrote the capstone project myself without using an LLM, and then I went through and wrote it again with the LLM. The LLM version is much, much better. So we'll talk about the comparison between the two and kind of, why I think it's better. And hopefully through this, you guys will become more proficient in using it. Um, one thing about AI is it abstract or is it relatable, right? Um, Things like autocorrect is a Netflix recommendations are AI. These are all things where AI is in our life, but we don't actually use AI. And it has been for years. It's gone from algorithms that are invented by Google and Netflix, and they've incorporated this into LLMs, which are just an extension kind of that same basic logic. So it's pretty fascinating how this has all kind of come to fruition. And then, what AI do you use every day without thinking about it? How many people got spam mail in the last week or so, right? Did you click, this is spam? You were labeling uh, a sample for the AI that runs your spam detection. So, these are all kinds of things that we do all the time. If you get a CAPTCHA, that's AI. So there's a bunch of stuff that's out there that I won't say is invisible, but it certainly is. We don't think about it as being AI every day. So the core, though, idea is that we're teaching machines to recognize patterns that humans might miss. And why is this important? Any threat hunters out there? I mean, how much can you threat hunt, right? You're doing endless queries and pouring through Splunk logs and things like that. What if there was a way to say, based on this sample, I want you to go through and find everything that matches the pattern? That's what we want to try and be doing with AI, right? Is reduce AI is it never gets tired. It's not tedious for it to go through and use a model to go through and analyze tranches of logs, right? When I was at Microsoft, I had, petabytes and petabytes of logs that we used to go through, looking for, you know, uh, who knows what PII. We would look for credentials. We would, look for data leakage and stuff like that. And we were developing AI back in those days, right, using Spark and pipelines to try and scale to be able to do that. And that's, I think, the benefit of using AI powered tools is scale, right? Is you can take what an analyst has to do manually and you can scale it through automation, and it makes it much more feasible, right? There's, um, some of the files that we look at, you could probably come up with a pattern or a search string and you could go through these log files, but how long would it take you to label samples? And we're going to show you this with malware, where we have a malware detection proof of concept that will go through and actually gives you a file and says these are the most suspicious files or data flows and things like that. So it's pretty interesting. Certainly a lot different than things have been done here recently. And then I guess the other thing is, artificial intelligence is only as smart as a person that puts it together, right? So the future is not AI is going to come and take our jobs. We're going to tell AI what we wanted to do so we can do more with it, right? It mimics intelligence. It's not actually intelligent in and of itself. And that's part of the value that we're able to provide because we're trained and able to do things. And make an AI bend to our will, right? It's not our master, we're the master of AI. And AI is not going to replace cybersecurity professionals. Now, I'm going to get on my soapbox here for a second. What is happening is AI is doing the job that a class of entry-level cybersecurity professionals used to do, the tier one analysts, the people who are doing hunting, the people that were looking at alerts and classifying them and doing that kind of stuff. That work's being done by AI. So now, where are the next generation of people coming from who are going to be trained in cybersecurity that are going to be the AI wranglers? Right? This is a big challenge. We need to. It's been a fundamental problem in cybersecurity. I don't know about you guys, but if you go and look at jobs, it's like, oh, hey, we want an analyst tier one with 8 years of experience and a CISSP and a college degree. It's like, who on in their right mind is going to work as a tier one analyst if you have all those qualifications, right? So we need to get real in an industry about how we grow talent and we bring up their next generation of people. And I think the attitude's got to be is I'm not training somebody to go and sit and punch the button on tier one every time an alert comes in and classify it, right? I want to teach that person to use AI to do that job so they can do more of it, right? So things are fundamentally changing. I think it's somewhat broken now. This is the same thing that's happening with developers and PMs and everything else, right? Lots of people are out of jobs now because it's like, oh, we're going to get AI to do it. Well, they're going to find out that AI is not going to do an effective job unless it has somebody driving the bus. And we're going to be those people, right? We're going to learn how to do that. And that's going to be part of what we're going to take away from this course. All right, I'll get off my soapbox now. Sorry. Okay, so what are the different types of machine learning, right? How do people learn? If you have kids, how do kids learn? They see the same thing over and over again, and you tell them what it is, and they learn what, for instance, a cat looks like, right? Could you show somebody what a cat looks like and show them a yellow cat, and then you could show them a gray cat, and then you could show them a calico cat, and they would know it's a cat, right? Even if they don't understand why they're all the different colors, they get the basic general characteristics of it. And that's really what we're doing with AI is we're teaching it to recognize a cat, right? And if you look at it from a standpoint of spam, right? The example we used before, when you mark something as spam, that's telling AI that, hey, this is a pattern that you can add to your definition of spam so you recognize it. It's not just a specific example of spam, but it's adding to the overall model, right? And if you have 10,000 examples of spam and 10,000 are not spam, and you train a model in artificial and machine learning based on that, it's going to learn those patterns, right? So the more examples that you present to AI, the better it's going to perform. Um, some of the examples I did for this course, just for the sake of time, I went through and I tested them with a subset of the overall data that I was going to send through it. And it's interesting, you get definitely different results with a smaller and larger data set. And we'll see some examples of that working as we go forward. Um, so let's think about, email spam. What kind of patterns do we think that email spam exhibits, right? We have senders with strange addresses. We have different kinds of words. So there's pattern recognition. There's NLP, neuro linguistic programming, where we're looking at the content of emails. Uh, we look at volume. So if I, from the same sender, get 10,000 emails into my enterprise that have the same subject line, that's probably an indicator. I can train a model to do that. So these are all some of the ideas that you might be thinking of as we are going through and trying to train a model. So the cool thing about this is, right, is we don't have to figure out the rules, right? It's a lot different if you look at an example of malware, for instance, and it's all diagrammed out for you. But how would you recognize the patterns in a large scale swath of data, right? You might be able to recognize an individual example, but how do you recognize patterns? This is where some of the traditional examples, like IDS has failed, and why we've had so many problems with vulnerability scanning and things like that, because we're trying to match patterns, right? And we're not looking at the overall context of what's going on. So pattern matching had its day, and I think it was somewhat of a failure. And now we're using AI and machine learning models to do that same kind of work, right? So we are able to go through and label examples of the different types of behavior, and the algorithms find patterns that we can't even see as humans just because of the scale, right? Is the amount of analysis you have to do on one sample, and then you multiply that by n number of samples, it's pretty daunting. And we're all humans. We get tired, we get bored, we get sick of looking at the same old thing, and that's why that doesn't scale, right? So we use ML and AI as tools. um, I alluded to this before. The more examples you have, the better result you get, right? So a strategy we're going to do is this is kind of interesting, because it a lot of times the data we want to look at is large, and you can't necessarily feed an LLM a huge chunk of data and ask it to do analysis on it. But you can take a subset of that data and you can ask it to build a model, and then you can do the large scale analysis. And we're going to show some examples of this moving forward, right? So if I have an example of labeled network attacks, let's say, and I have 80 gigabyte file, I can't feed that to cloud and say, hey, take this 80 gigabyte file and create a malware detector with it. But I can open that file up, and it's a little bit of tedious work, but I can take a subset of that file and put it in a CSV and feed it to it and ask it to build that same model. So I think that's going to be helpful, and we're going to learn some techniques for doing those kinds of things. And then we talked about pattern recognition, right? There's patterns that we can't see as humans. We'll see some of this in malware examples that we're going to do, and network attacks and things like that. Um, it's easy if you're going through and looking for a keyword like Mimikatz, right? Or you're looking for LSS process dumping and stuff like that, right? Those are all known kind of activities, but adversaries are getting smarter than that, and they're not going to give you an easy time. But we can see patterns, and we can see behaviors that might constitute something. And this is something like malware, where you've got polymorphic malware that changes the characteristics change. There's different kinds of samples. But what are the key things that show up as anomalies, right? It's the Where's Waldo effect. What thing is not like the other things, and how do you find it? And that's where ML and AI come in and are super good at it. So, and again, it's back to, it has to be trained, right? You can do unsupervised learning, which means that um, the anomalies aren't labeled, but somebody still needs to go through and decide what is going on and tell the agent what you want it to do, right? It's not automatic, and I think this is hopefully what you take away from this class are some strategies to be able to start doing some of that, or at least have the conversations about it. I think a lot of times, we're at an interesting point in the industry. It's happened in every tech wave that I've seen over the past 40 years, right? We're at the appliance phase, right? I'm going to give you this Docker container, and it's got this thing that you run in your Google Cloud, and it finds all the malware for you, right? And it's just a black box, right? But what hyperparameters are you tuning in that? What algorithms are you using? What model is giving us these results? It's qualitative. You're getting a qualitative answer, but there's a quantitative underpinning, or there should be. And we have to be able to understand that to make sure that it is tuned and it's appropriate for our environment. So, these are some of the things hopefully we'll take away. So deep learning is a subset of machine learning, and it uses, it's like a human brain. It has layers that look for different features. So, like in photography, you have an algorithm and it goes through it and it looks for edges, right? And then it looks for shapes, and then it looks for objects, right? So it builds upon itself. And that's, what deep learning does, is it's that build. And we're going to actually show an example of this, of how it uses techniques like um, a sliding window to look at a portion of the photograph, as opposed to looking for the whole thing. So I'm going to go through and I'm going to take a small bit of the surface area and I'm going to look for an edge. And then when I find the edge, I'm going to keep looking for more edges. And that's how I help build that definition. So there's different layers of the algorithm that look for different things that help it make a decision. So machine learning works with structured data usually. So if you have like log data, malware data, features, and things like that, uh, it works a lot better. Deep learning excels with unstructured data, so images, audio, and text. It doesn't fit neatly into rows and columns. And it's a lot of times it's a combination approach of the two that you're able to use to help you get results. So we'll talk about those, what's called ensemble methods, and you'll use a combination of supervised, unsupervised, machine learning and deep learning to help make some decisions. We're going to do some stuff with NLP that's pretty cool. Now, the other thing about this is, this all sounds super mysterious. We're doing this in the context of a platform called Scikit-Learn. Scikit-Learn has all this stuff built in, so we don't have to go out and find all the different implementations of it. It's good for doing prototyping and learning, and it's pretty amazing what you can do with Scikit. But the cool thing about it is that you can build a proof of concept in Scikit, and then you can scale it out using different platforms depending on your need, right? This is where, you might want to consult professional development help, but at least you'll have a proof of concept to go forward with. So, if you use a LLM like ChatGPT or Claude or Gemini, those use deep learning. Things like face recognition, fingerprint recognition, that's deep learning, right? If you've ever done, enrolled a new fingerprint, you have to touch it like 10 times at different angles and stuff like that. That's an example of it learning different parts of your finger, right? And um, then, like a self-driving car that uses deep learning to see the road, right? It's not really seeing the road. It doesn't have vision per se, but what it does is use a combination of these algorithms to do things like I'm looking for the edge of the road. I'm looking for dogs and cats and people and things that might, look be dangerous if it runs out in front of me. And then objects, right? I'm looking for cars and bridges and stuff like that. So something really interesting. This is a few years ago now, but I took my daughter down to college for a visit, and it was down in Silicon Valley. And we went to a mall in Atherton, and they had a security robot there. And it was one of the first ones. That was called Knight was the company. I think they still do security robots. But I saw something that was really fascinating. Is there was a sign up for like a kids zone that had pictures of children on it, and it was a poster. And then we were sitting there, and the robot rolled up, and it wouldn't go any further because it thought there were people standing there because there was pictures of kids on the poster, right? So these are all kinds of things that technology gets better over time. It does a better job using sensors and things like that to make these decisions, but it can still come to an incorrect conclusion, and a lot of times it's going to err on the side of caution, right? So this is we'll talk about precision and recall, right? It's, recall, it makes the wrong answer, right? So we'll talk about that, I think, in the next lesson. Precision and recall, remember those. Um, so really, what's the big picture, right? Uh, you know, AI is uh, an all-encompassing category. Machine learning is a subset, and then deep learning is a subset of machine learning. So they're each more specific. And for instance, all deep learning is machine learning, but not all machine learning is deep learning, right? And we can talk about that a little bit more, but think about that, right? Is there are parts of it where we use neural networks to process that work on unstructured data, and that's part of machine learning because it can be part of some of these ensemble methods. But you can still have machine learning like the logistics algorithm that isn't deep learning. It's just simply statistics, right? Boring old statistics. And again, to foreshadow a little bit, we can talk about some of this in our next lesson as well. So, AI is smart machines. Machine learning is learning machines, and deep learning is learning machines with a brain-like network, right? So that is kind of how I try and differentiate it in my deep learning brain is the computational statistical stuff is machine learning, but making decisions based on things that aren't necessarily statistical based, where you have to do some more analysis and come to a conclusion, that's generally more deep learning centric. All right, so now that we have a little bit better understanding of what AI is, how does it work? There aren't these, we're not going to talk about like theoretical things. These are tools that are being used right now to protect organizations like yours. And then as we're going through these, think about what AI is looking for and what would be difficult for a human to detect, right? Back to the hunting example, is I can hunt and hunt and hunt and I find one indicator of compromise, but I've still got petabytes of logs that I need to go through. And how am I going to automate that? Do I write a script? Am I pattern matching, right? What if the pattern's a little bit off? Um, Dumb example from the past, right? You could compile Mimikatz and you could call it something different. So Mimikatz isn't an executable anymore. Same thing with proc dump. You can recompile proc dump, so it's not proc dump. So if you aren't looking for LSAS dumping, you're looking for an executable, you might miss something. So that's kind of a decent analogy. Okay. So here's an example. Let's talk about malware detection. So who remembers the bad old days where you had a giant database and had samples of all the malwares that had ever been detected, right? And it didn't really get you the new ones. David, you raised your hand, your mic's off.
Yeah, no, I'm just saying I agree with you.
Okay. Two, if there was a two hands up, right? And this is the same reason that IDS failed. This is the same reason that vulnerability management drives us crazy, is that we're trying to pattern match based on a database of everything that's known. When I worked at Google, when I went through new employee orientation, one of the presenters had been at Google for a number of years, and he said, my job when I joined Google is every night I downloaded the internet. And he said, that's right, I downloaded the whole internet. Right. So we've come a long way since we downloaded the whole internet. I remember when I used to be a director of engineering in a vulnerability management startup, right? It's like all you had were your signature files, right? So, uh, and it's still the same problem. Vulnerability management, SAST, uh, you get a ton of low quality alerts and things like that. And you're spamming your end users and they get alert fatigue, right? What if you could say, okay, I'm going to go through and I'm going to do analysis of these and I'm only going to forward like the top 10% of high quality alerts to people so they can actually do something that's useful. And the rest of it, it's a different kind of campaign, right? So this is the kind of stuff that we're going to hopefully take away from this course, right, is how can we do this type of work a little bit more effectively and intelligently, right? So the new way, right, as opposed to having a database, is that we recognize types of behaviors, right? We recognize characteristics of, who knows what directory import functions, strings and files, right? Patterns related to different attributes, different features, right? We'll hear this again and again, features, right? So what's a feature? If you've ever opened up a spreadsheet, all the columns, every column is a feature, right? So some features are have entropy. Some features are fixed, right? We don't necessarily care about the features that are fixed. We care about features that have entropy. What does entropy tell us? Do things that are far out of the normal, this is back to the Where's Waldo example, right? We're looking for something that's different than the norm. And that's hopefully going to give us an edge in how we detect what is malware or what is potentially an attack. We'll have some examples of this later on, but that those outliers and those differences are the things that we're going to key on. And sometimes they're so subtle. Could you imagine how long would you last sitting in front of a SQL query going through line after line after line, trying to figure out, what's different about the contents of this cell in this column versus all the other ones? uh, and then spread that out amongst a bunch of different features. It's not doable for a human, but that's how we can use AI and machine learning to help us do some of that work, right? It never gets tired. It doesn't get bored. If you tell it to do the right thing, it's going to give you a good answer. Um, so 0 days, right? Uh, it used to be, hey, the 0 day would come out, and until you got that signature file, right, you're closing a port on a firewall or just doing something else. Now we're looking for behavior. Here's a story. This is from a long time ago. Back in the early 2000s, when I worked at Microsoft for Trustworthy Computing, we were analyzing crash dumps. And what we were doing, looking in crash dumps, were for executables that had never tipped over before, right? So when we started seeing the first indicators of these, what we realized is people that were developing exploits, sometimes they were targeted for a specific customer, they were still sending us crash dumps. So we were able to go through and analyze crash dumps looking for anomalies that helped us lead to actual compromises that were being tested before they were even released in the wild. So that data is there, right? And we have the ability to use that to get inside of the decision loop of our adversaries, right? So, uh, as they change their tactics, for instance, we're going to recompile Mimikatz and it's something else, right? We still recognize that same kind of behavior with the process dumping and stuff like that. So we care about process dumping. We don't care about Mimikatz, even though Mimikatz does process dumping. So, that's one way to think about it. So, how many times does phishing and malware and stuff get by all the gazillions of dollars worth of detectors we have in our company? Uh, quite frequently, right? It's the Even though every vendor says they have AI, that's a black box. If you're able to ask them some more detailed questions about, well, what's your AI doing? What algorithms? How do you train your data set? How do you get labeled samples, right? Is this supervised learning? Is it unsupervised learning, right? These are all questions that you should be asking your vendor, and you're probably going to get the sales guy saying, "Hey, can I take you out for a beer?" But it's seriously, uh, you know, forearmed is you'll be prepared to go and have these kinds of conversations. um so so that's one area where AI is making a difference, right? So and we talked about this a little bit, polymorphic malware, right? It's the same malicious intent, it's a different fingerprint each time, right? Every sample is different because they tweak it in some small way. We'll see some examples of this as we're going through and doing our capstone project with a malware detector, right? What is the difference in the features that leads us to believe that this is possibly malware? There's a fascinating research paper I'll share with you that talks about um, the virus total and some of the files and the Ember data set. And it's all really fascinating how researchers take logs and they process them so that the features correspond to activities in these samples of malware, and you're able to train models based on. So, and we'll be using some real data that it comes from some of these log samples I shared to help prove out some of these points. And again, AI looks at the behavior pattern, just not the signature. So remember that that's super important, right? Is where we're going, we don't need signature files. So for intrusion detection, right? This is an area, had an interesting experience when I was leading the blue team at Bank, is the attack surface is enormous. And we had a case where people were basically, password spraying, port scanning, and password spraying. And I had a conversation with one of our executives, and I said, "Hey, we need to do something about these ports. If we're not using them, shut them down." The guy's like, "Well, what's happening?" I said, "Well, we're doing port scanning and password spraying." And he said, "Has anybody gotten in?" And I said, "No." He says, "Well, why do I care?" I said, "Because it's costing you $4 million a month." Right. So literally, I mean, if you ignore some of these things, it costs you real money. So that's the kind of insight that we can bring to the table. That's not necessarily, oh my gosh, the sky is falling cybersecurity stuff, but it's more about quantitative answers in a language that our partners care about on the business side. So uh, we'll use these techniques to do that. You know, Pattern recognition, right? Um, had another case where we were looking at login locations and we found anomalous activity from a competitor. And it wasn't the competitor trying to hack us, it was somebody that had left the company and had left an account behind and they were logging in from the competitor. And, how do you find that kind of stuff, right? Unusual activity, unusual data transfers. Um, you know, Accounts accessing things that they never accessed before, impossible travel coming in from a strange location. I'm sure everybody that has online banking has probably experienced this at one time or another, where most of the time you log in and it just accepts the saved credentials on your phone, but every once in a while you get a challenge, right? Why do you get a challenge? Maybe you're coming in from an odd location, maybe you're coming in at a different time. Actimize does a good job of this, but it's asking you to take additional action just in case your account has been compromised. Impossible travel is always a good one for hunting. I have a story about that. I'll tell in a later lesson, but it's kind of funny. Um, you know, data flowing to countries that you don't do business with. It's like, why do we have open connection going to a North Korean address block? We'd want to know that, right? Um, and if and here's the important lesson, right? Is are you looking at atomic detections, right? Which is a one-off situation where a condition has been violated? Or are you looking holistically at the entire estate, right? Are you taking a big picture view and looking for patterns, right? If we would have better network monitoring maybe in 2020 for solar winds, maybe that hack doesn't happen, right? Because we detect these kinds of patterns, strange things going on. But hopefully we learn from that. So example three, like phishing, right? This is uh still a huge problem, right? It's getting sophisticated. You can get fooled easily, right? Especially if you're not paying attention. Different companies have better and less effective approaches. One of my favorite pet peeves are the ones where they do a phishing campaign, and if you click on a phishing email, you have to go and take some remedial training or something like that. What a load of nonsense that is, right? If people do things that cause a security compromise, it's because your security isn't good enough. It's not because your people aren't trained. So training is not a control. Phishing campaigns are not a control, right? If you have an issue with phishing, you better figure it out on the front end before that mail gets to somebody's desktop, right? Block that connection, do something. But anyways, I'm up on my soapbox again, and it really is ineffective, right? That's a quantitative or a qualitative approach to a quantitative problem. So better use of AI and ML as opposed to the phishing campaigns would probably be a lot better for everybody, right? What if you did a phishing campaign and your email system caught all the attempts and blocked them, right? Hey, wouldn't that be a novel idea instead of sending somebody off for remedial training? But anyways, I digress. So you know how I feel about that one. and uh and now the other thing too is AI is doing phishing. So it's not, some fishing farm in some far-flung corner of the world, right? Now we have, the AI arms race where you have people using malicious AI against your actual AI, right? What if I can take my phishing campaign and I can figure out where your your AI agent at the front end will let me through with the phishing email as opposed to flagging it and blocking it, right? What if that's the decision boundary? What if I can figure out the decision boundary and kind of reverse engineer, for lack of a better term, your AI so I can still send phishing emails, right? I can do that with machine learning and AI too, right? It's the same thing with patterns. So it goes both ways. Um, and so it's there used to be I don't know if it's still a magazine, Mad Magazine. They used to have this thing like spy versus spy, right? It's like we're in this AI arms race and it's spy versus spy, and who's gonna outdo the other person? And that's kind of where we're at because our adversaries are using it too. It's the same problem they're solving is the human effort required to mount a large scale campaign is becoming less and less because they're able to use these tools. So, you know, it's like, what makes a phishing email convincing? I don't know. It's the subject line. Is it sent just to me? Is it sent to a bunch of people? I check if I get an email that I'm suspicious of, I always check to see who it's from. And it's like some ludicrously long address at some random company that has nothing to do with Comcast or Xfinity or whatever. I'm probably going to mark that as spam. So I'm helping train the AI agents so they can detect it next time and move on. Right. I I went to a conference and there was a session where someone was talking about, phishing and spam. And they said sometimes they intentionally have bad emails because they figure if people are dumb enough to click on a bad email, they're probably more susceptible to being phished. So, there might be something to that. I don't disagree. Um, and then, if we think about how AI spots things that humans would miss, right? What if you have a convincing subject line? Maybe it's even from somebody right? A vendor has been compromised or something like that. How do we figure out if it's phishing, right? As a human, we're probably not going to go and open it up and look at the email headers and all the other different metadata associated with it. But if you have an agent that's doing that for you, um, that's going to be a lot more helpful. So examples like sender reputation analysis, again, this is, a heuristic where you're looking at how believable is it that this is an actual sender. Some of the things are obvious, other things aren't. Um, where do the links go? This is a classic, right? Hey, just open this PDF form and fill it out and we can cancel your Norton subscription or whatever, right? Where those links to go? That's like safe links in Outlook. That's a good example of this kind of technology where it actually goes and looks at the links and will replace them so you aren't directly hitting a malicious link. And then, content analysis, NLP, right? Looking at the language, the sentiment, those types of things. If you look at NLP for phishing detection and things like that, there's a bunch of parameters that you can adjust looking for that, right? Sentiment and those kinds of things. It's all very fascinating. All right. So what are the key takeaways? I told you I was going to go over. Sorry. So, right, what are the big things that we want to take away from this, right? Is that we are learning from data. We're making inferences from data, right? We're not guessing. We're analyzing data. We're looking for patterns and we're doing it at a scale that a human can't do sustainably. Um, I think everybody in their career at one time, there's been some process that you have to put on your back and you're doing it with, 4 spreadsheets and a PowerShell script and a couple other different things, right? That's not sustainable, right? You have to be able to scale, especially today in where things are at cloud scale, right? You can't carry something around on your back. You have to find a better way to do it. And we've got to be able to protect. I mean, I think people focus on the wrong things in cybersecurity sometimes. I call this CISO disease, right? I've got people that are worried about, the Princeton RAM freezing attack or some other esoteric thing that they heard at RSA, and it's a top priority. We got to take care of it, right? And that's not where we're getting compromised. Most compromises don't happen by a 0 day. They happen by somebody just doing something that's dumb, right? A lot of it is hygiene. This has been my mantra for my whole career, right? You know, 90% of compromises are just based on bad hygiene. Something's misconfigured, somebody clicks on the wrong thing, right? But the volume and scale of those things coming at you, right? How do you figure out, is everything properly configured? Do we have the right you know controls in place? Are they implemented effectively? As a human, you can't go through thousands or millions of hosts. I've had roles where I've had multiple millions of hosts that I had to look at, And as a single human, you can't do that, right? You're not going to get configuration spreadsheets or anything else like that anymore. I mean, that just doesn't work. So we have to use uh, tools, and machine learning and artificial intelligence are part of that to help us find problems, right? What if we could go and look across our entire fleet and find, places where we had incorrect configurations based on a control statement, right? And I mean, there's tools that do that, but how do you show trends, right? How can we do some analysis? And this is all part of the tool set that we're going to be exploring. And so it's all about, power. It's more powerful than human, but it needs a human to tell it what to do, right? It's faster than a human, but only if it's properly trained and somebody pays attention to it, right? It can scale, but only if a human is in the loop, right? There are some really interesting things that I ran into while I was building some of the examples for this course, where I would go through and I would test with a small file, and then I would go try and test with a big file, and my machine would run out of memory and barf, right? So you have to be able to understand what's going on and be able to do things like tune hyperparameters, right? How many iterations are we going through? How much data are we looking at? What changes are we looking for in some of these algorithms, right? And this is some of the stuff that we're going to be working through. And and things like pattern recognition, right? As humans, we can recognize a pattern, right? You could use R and you could probably document some small number of patterns, but how do you do that at scale, right? You need to build tools that take stuff at scale and do this kind of stuff for you. Um, so that's kind of it. Questions. I told you I was going to go over and I ran almost 15 minutes over, so I apologize. And we're going to delve deeply into these over the next 15 weeks too. So don't feel bad if you don't have a lot of questions now. I'm not even going to.
Oh,
Chuck,
hello.
Amanda, I'm sorry.
Don't
All
worry.
right.
You call me Chuck Steven. How's everything?
It's good, Chuck.
Yeah, I have a question. So you spoke about awareness training, right? And that's why I brought up the question about the RMF process, the NIST 853 process. So awareness training is a security control that they have within the RMF process. And that's why I asked the question, do you think that the RMF process will be outdated? Because a lot of the controls that are in that process, to get an ATO is very manual, and like you said, that's not where attacks are coming from. So
Yep.
it has a lot of controls that are kind of like, documentation, policy, and configuration. A lot of I would say
It,
process.
it's quantitative.
Correct.
It's GRC theater. A lot of that, right?
Correct.
And I don't think the goal of FISMA or FedRAMP or anything else. And again, I'm going to put on my tinfoil hat here. It's a CYA conspiracy, right? A bunch of people are trying to cover their butts, and they're like, oh well, we did everything and NIST 853 and we still got hacked. It's like, yeah, because it's just a bunch of manual crap, right? But it is um there's qualitative security and there's quantitative security. I'm a quantitative security guy. I'll die on that hill, right? Everything is knowable, everything can be known, everything can be measured, everything can be monitored. And the reason it doesn't get done is because people don't understand or they don't want to do the work, right? It's like we can do training and everything's fine. And if we have a failure, we'll just do some more training. And that doesn't do diddly squat for you, right? I don't want to get into the story, but I had a case like this at Google where the one conclusion was that the reason that we're having all these compromises is because we need more training. And if you looked at it quantitatively, there was a specific reason we were having these issues, and there was a control that we could put in place that would prevent it from happening, right? And training never keeps people from doing dumb things. So I'll get off my soapbox now. Sorry, Chuck. All right, who's next? Jose?
Hey, Steven. A question about some of the training like procedures that we're going to be doing. So in order to, are we going to be doing any examples of like making sure that we train our AI in like a sandbox where it's like not gonna like learning how we can do that in a way that it's not going to be like taken for like the AI's own learning processes. Like if we were to want to apply what we learn
Hmm.
to a sensitive data set, and
Yep.
then we want to be able to do that in a way that is protecting that from future use or other people, querying the AI or LLM for that sort of information.
Yep, absolutely. That's we'll talk about that a little bit more. But what I advocate is this is you can use an LLM to help you develop your code, but you don't want to run it on sensitive data. So you want to bring that inside and run it on a machine that you have control over. So it's not like sending your file to an LLM. And I'll show you an example of how actually that can happen and you may not even know it. One of the demonstrations that I put together. I was looking at the code the other day and I was like, oh, this is calling a web API to do this analysis, and that's probably not good. So we'll talk about that a little bit. But what I advocate is this: is that you can give even just headers or a small sample of data to an LLM and it can create some code that will let you run it on data on your machine inside of your firewall, and you're not using an API necessarily to go out and talk to anything else. But that's a great question, and I'll definitely make sure that we highlight examples of that as we're going through this, so you know kind of where the pitfalls might be, because there
But
are
what,
potentially a lot of them, right?
okay, just one quick follow-up is like, because what I'm interested in is being able to apply some of the things we learned to be able to train an LLM, not necessarily just to run certain scripts or anything like for certain behavior, but like to be able to talk to the LLM on a data set that I fed it, that I don't necessarily want it to be public, right? And
Hmm.
so if I'm training it on something, on certain data that, let's say I created myself, and I don't
Yep.
want it to be, released to the public, right? I want it to be, kind of within my own confines of my system. Like, how do I get the LLM to like work with it in a way that like I'm asking it questions just like I do ChatGPT, but it's like not going to be used for training data.
Yeah, that's a great question. I one of the people I worked with at Amazon was doing some work around that with code scanning, and he actually had his own DeepSeek stack running that was completely disconnected from the internet, and that's way beyond the scope of what we're going to get into. But we can talk about as we go through some of these examples, especially the ensemble methods, how you need to be careful about putting that data out there. So we don't really get to the point where we're going to have a full LLM, but we're going to use LLM to help us generate code, right? So I use Claude a lot. I'm sensitive to what you're saying. I don't know, and even though I'm mindful, because even though I'm using publicly available data, I want to try and build sort of that muscle around being cautious with the data. So we'll talk about some of those techniques about how you can take a subset of the data or sanitize data, because it doesn't the when you do the analysis, you want to do it on your machine as opposed to just sending all the data to the LLM and have it doing it, because exactly what you're talking about is going to happen, is that's going to become part of the training set. So we'll talk about strategies to try and avoid some of that as we're building some of these examples. All right.
Thanks.
Yeah, you bet. All right. Anil?
Yeah, sorry, you might have mentioned talked about this earlier in class, but I came in late, so I'm sorry for that. My alarm didn't wake it
Uh,
didn't I'm in overseas right now, so it's morning here.
yeah, weird time. Well, this will be recorded, so you can
Oh,
actually go back through and watch it again. But I'm
okay.
happy to answer your question.
Uh, you mentioned how after a while everyone's gonna have even the malactors themselves have their own AI which will combat our AI in order to combat. So does it make it kind of like an arms race where like everyone kind of needs like the most updated advanced AI in order to combat like the most basic threats, or is it something that even like you could take like an earlier version of AI, earlier version, iteration of it, and then still cause still be enough to handle most threats, or is it you see you needing us having to like have the most up to date
I
AI
don't
just to be able to?
I don't think you need the most updated AI because, again, based on my experience, most things that get compromised are simple stuff, right? And what the adversaries are doing is they're looking for vulnerabilities at scale and using AI to power that. So it's not necessarily that AI is figuring out something that you couldn't figure out, or it's AI versus AI. They're using AI to look for vulnerabilities that are potentially exploitable and then to execute potential exploits against them. And they can do that at scale because AI provides that automation ability. But you have that same resource, and it's irrespective of version or capability of AI, to use AI as a force multiplier to try and go out and find some of these issues, right? It is it
Mhm.
so it's pretty fascinating. I don't know if you have done much with graph data. Graph data is fascinating. Like Bloodhound, where you use Neo4j. Uh, every company that I've worked for the past 12 years has used Neo4j to do analysis of their access graph inside their company, right? And do you think that a malicious actor is going to have that same capability?
Mm.
Yeah, I bet they will, right? So it's just looking for vulnerabilities at scale, I think, is a lot of it, and then using it as automation to automate the exploit, so you get more exploit attempts per malicious actor, I suppose. But
Okay.
there's AI as a service now on the dark web that you can contract for to help, run infiltrations and stuff like that. So I went to a presentation a couple months ago on something like this. So it's pretty trippy, and we can talk about that some more. But
Mm.
it's you're matching wits, right? You're using AI for automation at scale across the cloud to look for the same things that our adversaries are looking for. It's just you're going to shut the door as opposed to trying to exploit a vulnerability. That answer your
Okay.
question?
Yeah, yeah. I actually had one other follow question is kind of unrelated. Uh, did you mention anything about did you mention anything about the Jupyter notepad? I remember seeing something like that in the curriculum for like the one homework assignment that
Yeah,
has the.
yeah. So we're going to be using Jupyter notebooks quite a bit, and uh, Python, Anaconda is the easiest way to get there. And that's what we're going to run a lot of the code in, because I'm guessing that not everybody is comfortable running like Visual Studio Code. And actually, I think the presentation is a little bit better. So we'll be using Python and Jupyter notebooks to do a lot of the examples. And we'll talk about that more
Mm.
in the next class.
Oh, okay. So I want to make sure I
Nope,
didn't miss
didn't
it.
miss it
Yeah.
yet.
All
You're
right. Thank you.
foreshadowing. I'm happy to answer that.
Okay.
All right.
Thank you.
All right, Andrew?
Oh, geez, sorry. My apologies. Yeah, so my question is associated with if we pull the like machine learning, the LLM, and we pull our inspection down into like the system level, right? Like, have you had experience or can you give us like help us understand how you've authorized that from, you know what I mean, like an ATO perspective?
I'm sorry, I didn't catch the last part of that.
Um, so if we are creating like machine learning, you know what I mean, like these
Yeah.
resources for a government customer, do you have any experience in explaining like how you've been able to authorize that from an ATO perspective?
Yeah. So what I always am a proponent of is we don't use public LLMs to do analysis and give us answers. So we don't feed our data to the LLM. We use the LLM to help us write code that we run on our own machines inside of our environment. So our data doesn't go out and get put into the, results of like Chat GPT or Claude
Mhm.
or something like that, right? So we'll use that to write code, and then we're running Python code on things that are installed on our in our Python kernel on our machine, and we aren't using any external APIs. So we'll that thread will be woven throughout the examples and the labs, so that one thing, and this is an important thing. I'm glad you asked this question. We need to have, first and foremost, everything we do has to be explainable. So I need to be able to explain it to my CEO or a CIO or CSO or anybody else anywhere and have them understand exactly what it is that we're doing. Not that, oh yeah, we're using AI for something, because people are like, oh no, we don't want to use AI, right? It's like we are using machine learning algorithms running on a Python server inside of our firewall in a secure network that is doing this data analysis. And none of this data is ever going out and going to ChatGPT or anywhere else.
And then you can push everything back off onto like change in configuration management, and everything's internal. That's brilliant. Yes, makes sense.
Bingo.
Thank you.
And we'll show an example of that with a malware detection proof of concept that I worked up, where it spits out, there's one where we're going to look at like malicious traffic, and it spits out targets and potentially compromised hosts and stuff like that into a CSV file that you can pawn off on somebody else and say, hey, I got some problems for you to go fix.
Yeah, that's awesome. That's exactly like what I'm looking for, because I want to increase my ability, you know what I mean, within the government, but at the same time it's the government, so they tend to be a little bit,
Yeah, I know what you're saying.
Thank you so much. I appreciate your response. Thank you.
Yeah, you bet. Okay, Gola.
Yeah, I have a quick question. Lately there's been, I would say, some noise about MCP, and actually today at work, because I'm also into kind of like AppSec, somebody on my team actually posted I would say it was kind of like a a bulletin board that talks about MCP and the vulnerabilities that comes with it, and that we might, later down the line be doing some threat review for that. So I
Mhm.
wanted to ask if we are also going to be touching on that, from a security perspective. Be one of, the things that we hear about the most, especially, in conjunction with AI and this AI rave that's going on at the moment.
Yep. To a lot of people, AI is still the boogeyman, right? They're whistling past the AI graveyard because they have CIO disease, right? And they've been to a briefing, or I went to RSA and somebody said something, or I went to a seminar and they're talking about all the doom and gloom and stuff associated with AI. At the end of the day, machine learning drives AI, and machine learning is statistics, right? And that's all it is it's really fancy statistics. And there's a lot of models done by PhDs that are 1,000 times smarter than me. So I can't tell you exactly how they do all the stuff that they do. But at the end of the day, it's like a giant spreadsheet, and you're analyzing the data that's in there looking for problems. And that's part of it. Deep learning sounds scary, but it's not. You have algorithms that you use to try and do analysis and things like that. So are there vulnerabilities? Yes, right. It depends on how you're using AI, right? There's the stuff we're going to be doing. A lot of it is machine learning based, but we'll talk about how does this feed into AI, right? You have algorithms that you're using and things like that. If you build a large enough solution based around some of the techniques that we're going to be looking at, like these ensemble methods, right? You can power those with AI, but there's a difference between like a LLM, which just is like the entire internet in a big if statement, right? And machine learning, where we're actually going to be doing some analysis. So we'll talk about the differences as we go. All right. James?
Hey, Stephen, thank you for kicking us off today. Had a quick question. Couple questions back. I think you were talking to Jose about the importance of keeping data privacy in the forefront when you are working with LLMs, say, and you're dealing with sensitive company data, you're developing something, and you mentioned an example where you are working with this model and you were feeding it data and you saw that it was making outbound API calls to a third party. Was that just you checking the network tab, or was there something else there? I was just curious about that
Well,
example.
no, it's kind of that's a great question. So, I was feeling adventurous, and I asked the LLM to take the code that it wrote for me and add an interactive web component to it, and it did, and it's like cool. I posted it in the chat, and I was like, hey, this is neat. How does this work? Is this running Python? Is it going against my
I see.
the Python kernel I have running on my machine? Where's this stuff going? And I looked, and it's like it's going to some Ajax API out on the web. I was like, oh crap, that's not good, right?
Mhm.
So that's the kind of stuff, right? You have to be curious and look at things in detail before you operationalize them. And that's why, we should always do threat models. And, the stuff that we're doing here is proof of concept, right? Grade stuff. And if we get something that we find that is interesting that we need to operationalize, probably need to sit down with a real developer, right? I mean, we're doing science projects, and you can do some really cool stuff, but none of this is production quality. But that's the reason why, right? That vibe coding is dangerous, is because if you don't know what to look for, if I wasn't a software and security expert and I didn't know that I'm going to hit F12 and see where this is going, right? And look at the code of my IDE. I could have just fed that data all day. It's like, hey, look at this neat thing I got,
Yeah.
right? So yeah, we're going to talk about that a lot, because I mean, all these are great questions, because everybody has fear, for good reason, of AI, and especially stuff that happens with vibe coding, right? And if you're not AppSec person, and I've done AppSec, I've done just about everything under the sun, right? So I've got all this crap running around my head. I was like, oh man, I better go check that. And sure enough, right? So great question, and we're definitely going to be looking at that kind of stuff as we're going.
Great. Thank you.
Yeah, you bet. Diraj?
Yeah, it, it's basically a follow-up question to what Jose was mentioning about the data set. Um, can you hear me?
Yeah, I can hear you.
Oh, okay. So basically, following up on that, like we know that we use like either Claude or ChatGPT or Gemini, which are the most common models, but there is also a local model, which is like an Olama or a DeepSeek, which we basically keep it to the local and not allow any external API communications. So what would you prefer to use for our AI engines? Like, would it be good to use like a Claude or a ChatGPT or Gemini versus using an Olama or a DeepSeek local ones?
For stuff that's production, where you have sensitive data, even though it's a heavier lift, having your own internal AI is preferable, because it can gatekeep what gets in and out, right? And what we're doing here is we're using LLM to help us write code. We're not just turning data over to LLM and asking it for results, right? So there's a subtle difference, and it's a great question, and we can discuss this some more in further lessons, right? But you know, I am dubious about ever turning any sensitive data over to any LLM that I don't have full control over. So that's my bias. You know, we had our own internal version of Anthropic at Amazon that was firewalled off from the internet. So we were able to use it for certain classifications of company data, but it's a real problem, right? Today, especially, again, I don't want to knock vibe coding because I think it's pretty cool. But if you don't have the experience to figure out what's really going on underneath there, you could run into issues like the one I was highlighting, where it's like, oh, hey, I did this cool thing, and it's talking to some API someplace that I don't have control over, right? So we need to, as security experts, we need to think about this and how we approach it. And, you know, kind of my thing is that, you know, I can use an LLM to help me get a science project off the ground that I can run inside the firewall on a machine that I control to get a result. But I'm not gonna, you know, send my logs to Claude. You know, it's just not gonna happen.
Okay. Having said that, like, what about the models? When you have something like Olama and you want to do some analysis, do you need specific models on which, when you're working with data sets in order to make your analysis, versus you connect to an external API and it has like thousands or millions of models out there that can help you analyze the data better? So in that scenarios, how do we approach that problem?
I think it's like if you're familiar with like graphistry, right? You mean you can send data to the graphistry API, but you can establish a key where your data is secure, right? So graphistry will give you a result, but it doesn't your data is still secure. So I think you need to, whatever models that you're looking at using, you need to understand what their security model is. So do a threat model, see what controls are in place as you send stuff back and forth. I think anything that you don't control directly and have a detailed understanding of how the data is handled and what it's being used for, you don't just want to blindly send stuff to it. So if it's we're kind of in this course because of the nature of it, we're in the world of science projects and we're going to talk about security related to it. We're not going to be using some of the advanced features you're talking of LLMs that much. It's a lot of it is machine learning based and we're solving basic problems, right? How do I take a file sample that I have and how do I make a malware detector around it, right? So this is sort of the nuts and bolts of how you go through the process using machine learning. And what we're using LLMs for in this context is to help us write the code that lets us do the science projects. But you're asking a bigger question about how do we use publicly available models to get results. And I'll weave some time into a lesson down the road where we can talk about this because I think that's an excellent point. I'm not sure I've covered it in enough detail. So it's a great question. If you hold that till we're down the road a couple more lessons, we can talk about how do you use the world of models that are available to you? What if you want to do something besides a science project? How do you move forward to operationalize this? So we'll talk about, the security of AI itself, and I'll make sure we dive into that a little bit more deeply.
Thank you.
Yeah, you bet. Tutu?
Yes, hi. Will you be able to show us maybe like if you have like a intrusion detection system or IDS or IPS type of tool that will, if you can maybe run a scan on your network that is integrated with AI and show us like a workflow or something like that.
I have an
Something like
example where we look at network traffic, looking for doing anomaly detection for intrusions. I think that'll cover some of that.
network trafficking. Okay, so you'll be
Yeah,
showing
we do
tool,
have an example where we're going to look at network traffic.
and it's a tool that you have access to that you'll be showing like a lab, like something.
Yeah, it's a lab, and there's code you can take home and use for your own nefarious purposes.
Okay. Can you expand a little bit on what the is it the Psi kit is a little bit? Is it something that we have to download separately from Anaconda?
No, that's kind of cool because that's built right. That's right in the notebooks that on anaconda.com.
Oh, okay.
So that if you didn't want to jump out of your Jupyter notebook to use an LLM, Sidekick does that for you. So it's a good place to start. If you're not a LLM snob and you have your own LLM, a choice that you like me, then that's a good enough place to start.
Do we have to design a potential malware that is AI generated malware, or do we have to do something like that, or are you
No,
capable of doing something like that?
no, I have log sources of actual labeled malware and a test file that we'll be using. So we're not going to have to generate anything,
Okay.
right?
That tool, or it's just a prompt or something that you generate, or
Well, no, I actually have they're from Virus Total, I believe, but it's a data file that has some malware that has been optimized for machine learning, and we'll be using that. So it's just data, it's not actual malware.
but it's still AI, right? Okay.
Oh yeah. Hey, we AI all the things around here.
I just wanted to make sure so I know everything, all the tools and things like that, a list.
Yep.
So,
Yeah, I will, and that's actually a good point. I'll work with Paulina, and what we'll do is we'll come up with like a bulleted list at the end of the course, of all the great things that you now have been exposed to.
yeah, because it is so many different tools out there when you're looking at jobs, and it's so many different tools, and you never know which one is accepted, which one is popular, which one to focus on.
Yeah. And that's a great question, actually. So the last time I taught this course, we taught it based around a platform. We based it around Elastic. And some of the feedback I got is, well, what if I don't use Elastic? What if I use Splunk? So when I redesigned the course, this is more about concepts, right? And how the concepts of AI, how do you actually use them to get results? And then those apply to many different platforms.
Yeah, I'm glad you mentioned that, because because some organizations, their platforms, their environments are deployed on AWS or Azure,
Yep.
uh, or GCP. Um, do you discuss certifications that you will suggest at the end or at the end of the course?
I can weave some of that in. I've got certifications, but I don't know how big a certification person I am. I think that they're a necessary evil sometimes to get past the AI that's analyzing resumes, right? But I've been
I
a
train different
CIS.
certifications like the I think it's called the AIGS governance. And then
Yeah,
the Azure AI as well. The entry level, I think, is 009, I believe. Um,
I'll go and look at some of those. I didn't look at that specifically, but that's a good question, and we'll make sure that we pull some of that together for the wrap up at the end. Right? Okay, Swayam. Okay, and then we'll get to Andrew and one more question after that.
Yeah, hi. I have two questions. So my first one is like, what are the list of tools I should be using for this course?
What basically what we're going to be doing is scikit-learn is the biggest chunk of this, and scikit-learn in Python. So that's where most of this is gonna come from, and there's some Python stuff built around Anaconda. But as far as a platform or actual bespoke tool, we're not really doing that. This is more conceptual. So we're going to actually take you from where you have a log file and you read the log file in using Python, and you go through and your capstone project will do the analysis, and it'll create output and graphs and things like that. So we'll be using Python basically and scikit-learn for a lot of this and some other things thrown in, but it's all open source, I guess, if that's the question.
All right. So my second question is since I'm a student right now, I just finished my freshman year. I don't
Yep.
have much knowledge about this topic, so like what can I do or like what can I like read more to like learn more about it?
Great question. I will post some resources up in chat either later tonight or tomorrow for people who want to get started and have a baseline of knowledge. There's a bunch of stuff. A lot of it isn't very accessible as far as, you get into it, like the 100-page machine learning book. I used to think that was the greatest thing on the face of the earth, but then it's like I've been doing this for years and years. So I've got some resources that I'll post up.
All right. Thank you.
Yeah, you bet. All right. One last question. I don't want to cut anybody off, but some of you have asked more than one question. So, Alowafemi, sorry.
No, you got it. Thank you, Mr. Smith. My question is, would we be creating our own machine learning program?
Yes.
Okay, because I recently created a program using Hugging Face and Purple Llama for my school's research program, and I basically created my own AI program, and basically I could like ask it questions as if I'm texting or chatting with ChatGPT and other open AI sources. So I was just wondering if that would be something like what we're going to be doing in this class.
We're not doing LLM as much as we'll be doing the machine learning side of it. So we're going to be focusing more on like the quantitative aspects of it. So we can compare and contrast as we go. It sounds like a fascinating project, though. I think a lot of LLM stuff is cool, but
Yeah.
this is more machine learning centric.
Okay, thank you.
Yeah, you bet. Okay, so we're at time. Andrew, real quick.
Yeah, honestly, I have just a little bit of a fun question. Like, can you give us your insight on like what happened with Gronk this week? Because it had a little bit of a freak out, no?
There, one of the challenges, and I was at Microsoft. I don't know if you remember, there was a chatbot named Tay that was really the first kind of chatbot AI freak out. People learn how to push AI's buttons, and it's not as much as hallucinations, but if you can get it to ignore kind of its base prompt somehow, you can get these kinds of answers. And if you ask it enough leading questions, or enough people ask it enough leading questions, it will change its point of view and certain things will be able to pop out. Because I think the biggest danger of LLM is the fact that it's a giant if statement. And if you've ever done any programming, how many nested if statements do you get before you start getting crazy results, right? It's like exponentially beyond what you would ever be able to think of on yourself. But I think it's just people are able to use AI to poke AI's buttons, right? And that's I think an example of scale overcoming kind of the inherent base prompt protections that AIs have in place, right? Because you know you want your AI to be able to give you useful information. I think it's challenging sometimes that certain things are off limits if you ask LLM a direct question. However, if you ask the question in a certain way, you'll get answers, right? So if I ask an LLM for some advice about a security topic and I say, I'm a security researcher and I want to know how to do this, that, and the other thing against this kind of environment, it'll probably tell me. But if I just ask for that without prefacing it somehow, maybe it won't. So, but it's an interesting question. All right. So this is the last question, Niraj.
Yeah. So I have this. Uh, are you going to cover how to apply AI to threat modeling?
That's a great question. I hadn't thought about it, but we can. Threat modeling is one of my favorite subjects. I've actually been doing some work in that area. I'm trying to develop a way for AI to take code and look at all the interfaces in the code and create a graph of all the relationships. So we will talk about that now that you mentioned it.
Sure. And is there a way to save this chat messages?
Um, in the meeting chat, I don't know, Paulina, do we
Yeah.
save message chats?
I mean, usually, no, I don't see
Yes,
an
it will
option.
be posted next to the recording tomorrow.
Okay.
Okay.
Example.
All right, cool. And if there's anything in chat, I'll go through and try and answer it this evening so it gets posted with the recording.
Okay. All right. Thank you.
All right, cool. All right.
Yeah. Yeah.
So we're way over time. Sorry, I told you this is going to happen. But thanks for the great participation. And we'll get that content posted. And I'm looking forward to the next class. And if you got any questions, hit me up on Discord or, either in one of the groups, DM me or shoot me an email.